so I accidentally forgot to start the recording at the start of office hours today. So let me really quickly tell you what we covered in the last few minutes. We just talked about did we talk about angles and their measurement? And we talked about special right triangles, 45, 45, 90, 30, 60, 90. And we talked over an example here from the notes on how to find the points on the unit circle with height 3/5. But that's also back in the lecture notes. You can find this exact problem in the lecture notes. Then we talked about this example of finding cosine of pi over 4 and these steps 1, 2, and 3. Again, from the lecture notes, you can find this and hear that if you want to hear that. And then we only did one example here, which was to do tangent of negative 37 pi over 4. The way we did that was we had to add a multiple of 2 pi in order to find an angle which is coterminal to negative 37 pi over 4. So we chose to add 10 pi because 40 pi over 4 would be just enough to cause this angle to be between 0 and 2 pi, which is what we want. So we did that. After that, we just followed the usual steps for finding the tangent, namely put the angle inside, draw the line segment, finish the triangle, and find the coordinates of this point using the theory of 45, 45, 90 triangles for this example, but we might use a 30, 60, 90 triangle if the question was different. So that's how we got this answer. Okay, so that should catch everyone else up who's watching the recording. Okay, so any questions on this example for the tangent problem?
So why does it matter exactly that we turn it through the 2 pi, pi through 2 pi again? I'm slightly confused on that.
So the reason I do that is, look, you know that this angle points at a point on the unit circle, but you need to know, like, roughly speaking, where is it so that you can figure out what the angle inside the triangle is, right? So for me, I look at something like negative 37 pi over 4, and I can't do the mental calculus in my mind of like, where is that pointing? It's not easy for me to tell where is something like negative 37 pi over 4 pointing. On the other hand, something like 3 pi over 4, I'm like, oh, well, I know pi is going straight to the left, so this is like 3/4 of that angle. See what I mean?
Yeah.
So it's just to make the angle friendly for your brain to have a vague idea of what it is.
Okay.
You know?
Yeah.
Like, I think everyone knows how much of a turn is like 270 degrees or like 180 degrees. But if I tell you, like, you know, how much of a turn would it be if I did like 20,430 degrees? It's such a big number, you're kind of lost in terms of like how much that is, you know? So you gotta like find the coterminal angle, which is between 0 and 360, and then you can have an idea of like which direction I would be pointing after doing all of that nonsense. Does that answer your question?
Yeah.
Okay. Any other questions on this one? Okay, it doesn't seem like there are, so let's see what we learned next. Okay, we did a bunch of examples. And then we saw this thing, which, again, I don't think that you should memorize this, but this basically shows you what are all the possibilities of points that we could have on the unit circle, right? So this would be the 30, 60, 90 triangle, where this one's 60, you know, and so on and so forth. What would like negative pi over 2 look like? That would be this angle here, pointing straight down. Okay, and we'd get the 0.0, -1. So like sine of -π/2 would be -1, right? Because that would be the y value of that point on the unit circle. Okay, so that's that. So then we learned about the signs of the trig functions. And here I use the word sine with a GN, whereas sine with an E, NE, is the trigonometric function. So when I say sine, I'm talking about positive or negative. So if we have a point, we have an angle which points at a point in the first quadrant. That point has a positive x-coordinate, positive y-coordinate. Therefore, all of the trig functions will be positive. Because what is sine? Sine would be the y-coordinate, which is positive. Cosine would be the x-coordinate, which is positive. Tangent is positive divided by positive. What would cosecant be? It'd be 1 over the y-coordinate, which is positive. So 1 divided by a positive number is positive, and so on and so forth. You get the idea. If we have a point in the second quadrant, then we know that the x value of that point will be, sorry, I don't know why I did that. The x value of this point will be negative, and the y value will be positive. So sine will be positive, but cosine will be negative. That's going to cause tangent to be negative because we would take positive divided by negative is a negative. So sine's the only positive one. If we're in the bottom left quadrant, quadrant 3, the x-coordinate and the y-coordinate are negative, which means when we divide them, we're going to get a positive number for the tangent. But otherwise, sine will be negative, cosine will be negative. And finally, in the bottom right corner, we've got just cosine being positive. So the way you remember this is you say all students take calculus. It goes A, S, T, C. The order goes 1, 2, 3, 4, just like the quadrants. So quadrant 1, 2, 3, 4 correspond with A, S, T, C, respectively. Okay, so we already talked about angles bigger than 2π and the periodicity of the trig functions. We just incrementally subtract by 360 or 2π, or if you have a negative angle, then you incrementally add by 360 or 2π. Okay. This was more examples. We did a lot of examples. Oh yes, and then we learned, of course, the Pythagorean identities. So let's review these. What do they say? They say that if you take an angle T and you find the sine of that angle and you square that number, which is what this means when I write a 2 here, it means I square that number. Then, of course, sine of t is squared plus cosine of t squared is going to be equal to 1. Why? Because if you take the angle t and put it in the unit circle, what's going to happen? You put the angle t in. Looks like this. You go to the point, x comma y. Then what is true? Sine of t is equal to y. Cosine of t is equal to x, yes? So what is... Jesus, I don't know why that comes up. Okay, so what do we have here? Sine of t squared. What's that? That's just y squared. Plus cosine of t squared. What's that? It's just x squared. So of course this is going to be equal to 1, right? Because we're talking about the unit circle here. Okay, so sine squared t plus cosine squared t is equal to 1. So for example, what is sine squared of 0 plus cosine squared of 0?
1.
Yeah, just 1. Do I need to figure out what this number is and what this number is and then add them together to get the answer? No, I can just know that, look, the angle inside is the same. Sine squared plus cosine squared is always going to be equal to 1 as long as the angle is the same inside. Okay, you could also do sine squared of -π plus cosine squared of negative pi over 6, something like this. As long as the angle is the same on the inside of both, then the angle will be the same for both of them. We're going to get the x and the y coordinate. You square the x coordinate, add it to the y coordinate squared. What are we going to get?
One.
Yeah, just 1. I don't need to do nothing. I don't need to actually figure out what this number is. How would I do that? I would put negative pi over 6 in here. I would find this point. I would find the x and y coordinate of that point, and then I would take the y coordinate and square it. And that would give me what this number is. But I don't need to do all of that. If you really want to, you can. But I can just say this is equal to 1. Okay, how about the other ones? Well, the other trigonometric identities, or the other Pythagorean identities, are given by just taking this Pythagorean identity and doing one of two things. Either we divide everything by cosine squared, or we divide everything by sine squared. The way you remember what you're supposed to divide by is you're trying to make either this, you're trying to turn this into 1, or you're trying to turn this into 1. Okay? See what happens when I divide by cosine squared? The second term here, which came from here, gets divided by itself, which means it becomes 1, right? Becomes 1. Or if I wanted to make the first term 1, what would I do? I would divide everything by this thing, which would be sine squared over sine squared, which would give me 1. Okay? So these are the other trigonometric or Pythagorean identities. They go tan squared of t plus 1 is equal to secant squared of t. Again, the angle has to be the same inside of both of these. Then we get 1 plus cotangent squared of t is equal to cosecant squared of t. Again, the angle has to be the same inside of both of them. Any questions on Pythagorean identities?
These weren't really on the 4.3 homework. Do we still? Okay. So actually, the last 3 had some Pythagorean identities, but it wasn't exactly that. Do we need to know them in that form, or will it be like it was on the homework?
Well, all of the quiz questions are copied word for word from the homework. So
Okay.
does that answer your question?
Yeah. Thanks.
But you know, what I can't say whether or not knowing these would be useful for completing some of those problems. I would say they definitely would be useful.
Okay, thanks.
Okay. All right. So yeah, like I said, this is not going to be true if you put a different angle inside each of these. If you put a different angle inside each of these, it's not going to be true. Okay, so next up, what do we got? Even and oddness of sine and cosine. And we determined during a partner practice that sine is an odd function and cosine is an even function. Okay, so that means that tangent is also going to be an odd function. Okay, it's going to be an odd divided by an even, which would be an odd. So why is sine odd? Because if you take the input and you switch it from positive to negative, what happens to the y-coordinate of the point? It goes from being positive to being the same number but negative. So opposite input gives us opposite output. That is the definition of a function being odd. We plug in the negative of the input, then the output will be the negative of what it was. And likewise for even, but slightly different statement, right? Any questions on even and oddness? Okay, if not, then I'm going to move on to the next section, which is where we learned how to do the graph of sine and cosine. Okay, so all we are going to do is we are going to, I'm going to go down to this first. What are we going to do for the graph of sine? We are going to allow the inputs on the horizontal axis to represent various different angles inside the unit circle. Then the input pi over 2 would correspond to an angle like is shown, and then that angle would point at a point on the unit circle whose coordinates would be 0, 1. And since sine is giving us the y-coordinate, that y-coordinate is going to be the height of the function for that given input. Are there any questions on how we get the height of the sine function when we represent it like this? Okay, can someone give me a one-sentence explanation answering the following question? My question is this. Why does the graph repeat? So after this, after we get to here, we're just going to continue this on. We're going to copy paste. We're going to copy paste on the end here. Why am I going to do that?
Is it because it's a unit circle, so like it all just keeps on going?
I'd prefer a more, can you make the statement a little more specific than that? I think you have the right idea.
I don't think I can. That's just the first thing I thought of.
I mean, you're generally correct, right? What's happening is the inputs, okay, are going to be coterminal to the inputs 2 pi earlier, right? Why is that? Because what does pi over 4 look like? That looks like this angle, right? Just like this. Can you see that? That's what pi over 4 looks like. What does 9 pi over 4 look like? 9 pi over 4 looks like this. And hey, look, it's pointing at the same point as did the angle pi over 4, right? So the reason that the graph is going to repeat is because after you go around 2 pi, where are you? You're back where you started, and then you're going to just do it all over again, right? And we're just going to go around and around and around and around and around. Yes? So that's why the graph is going to repeat. Any questions on that? All right, let's talk about some other things for sine. Namely, how am I going to find the values of t which will cause sine to be 0? Well, what I need to remember is when I take an angle t and plug it into the sine function, what does it tell me? It tells me the height of the point on the unit circle that that angle points towards. If the height of that point is 0, then the angle t must point in one of two directions. It must point either straight to the right, because this is one of the 2 points with height 0. It's the point 1, 0. Or the angle t must point directly to the left, because that would be the point with the other point with y-coordinate 0. So I want to understand what are the angles t which point straight to the right? Well, that would be 0, 2 pi, 4 pi, 6 pi. All of these angles point straight to the right. So 0, 2 pi, 4 pi, etc. point to the right. What kind of angles point straight to the left in terms of radians? The question was, what kind of angles point straight to the left in terms of radians?
Is it just pi?
Pi would be one of them. So that would be this angle. What would you call the following angle? I'm gonna not just go straight there. I'm gonna go all the way around and then to here. What would this angle be?
Pi times any odd number?
Yeah, that's what I'm looking for. So this would be 3 pi. If I were to go around one more time, then I'd get 5 pi, and so on and so forth. So the directions here is going to be pi, 5 pi, 3 pi, 7 pi, dot, 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 right? And also, of course, negative pi. Negative pi would also point straight to the left, except instead of going like this, negative pi is going to go like this, but still going to point straight left. So all of the numbers, all the inputs t, which will cause the sine function to be 0, will be the numbers like negative 3 pi, negative 2 pi, negative 1 pi, 0 pi, 2 pi, 3 pi, 4 pi, 5 pi, all of those numbers, right? Because those are the angles which point either straight to the right or straight to the left. So what do we see corresponding on the graph? Hey, look, when is the sine graph going to pass through the x-axis? 0, pi, 2 pi. If you were to go continue this on, it'd be like 3 pi, 4 pi, 5 pi. Those are going to be when the sine function touches the x-axis at 0 pi, 2 pi, 3 pi, 4 pi, and also negative pi. If we were to, this can be extended also to the left. This would be the point like negative pi or something like that, right? Okay, so those are the zeros of the sine function. How about the zeros of the cosine function? Well, they're going to be when we point straight up or straight down. So we just have to describe those angles. Okay, so we're talking like pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2, 11 pi over 2. It's all of the odd multiples of pi over 2. So we write the closed form of an odd number can always be written as 2n plus 1. This is always an odd number. In fact, this describes every single odd number if n is an integer. And then times pi over 2. Any questions on the zeros of sine and cosine? Okay, doesn't sound like there are, so let's see here. Yeah, we did. Yes, we still have a little bit left to go in this section. So how do I get the graph of a stretched function? So Jesse asked me a question on my email. So Jesse, if you're watching, this is for you. So if we want to do the graph of something like 2 times sine of x, right? Or 2 times sine of x plus 1, okay, then we're just going to use the theory of transformations, which we learned back in section like 1.7, okay, to apply a vertical stretch. So if the normal sine function looks like this, then this would be like, if we did 3 times sine of x, this would be the graph of 3 times sine of x. We just make the height of every single point 3 times what it was before. So 3 times 0 is 0, so obviously this is still going to go through this x-axis at the same points. But it's going to be stretched. Okay, it's going to be stretched. So we imagine just grabbing on here with our hand, and I'm going to pull in this direction. And I'm going to grab on here with my other hand, and I'm going to pull in this direction. Yeah, these little squiggles are supposed to be my fingers, by the way. So that's what I would be doing. I'd be grabbing that and pulling in those various directions. Maybe I can make that more clear with a better fist. grabbing, and this is like my fist. Okay, and I'm going to pull in that direction. That's much better. More like a bear claw, but. All right, so that's stretching vertically. Stretching horizontally, what are we going to do? We're going to multiply by a number on the inside, but of course, if that number is bigger than 1, if that number is bigger than 1, that's going to correspond to a horizontal shrink. And if it's less than 1, that'll correspond to a horizontal stretch. So how would I graph something like sine of 2 times x? It's going to do exactly what sine does, except it's going to do it twice as fast, right? That's a way you can think about it, is I'm doing things twice as fast. So it's going to wiggle real quick. Ooh, oops. It's going to wiggle real quick and be done in half the amount of time. Any questions on stretching vertically or horizontally? How would I get the graph of sine of x, but shifted vertically up 3 units?
Just move each point up 3 units.
Yeah, and what would be the equation for that?
Y equals sine of x plus 3.
Exactly. All we do is just add 3. And then what's that going to do? All you're going to do is take this whole thing and you're going to move it up 3 units. Okay. So same old transformations from before. All right. So then that was the end of section 4.4. So that's what we covered. Does anyone have one of those topics that they want to go back to, or maybe a homework problem that they were trying to study for the quiz with and they found it was kind of stumping?
Can we do one of the graphs from 4.4?
Sure, we can do
One of the
graphs.
harder ones, I
Okay.
think. There wasn't really one in particular. It was just like 4 through 7, like the ones where we have to look at the graph and then make an equation too.
Okay, let me look at that. Manage assignments 4.4 preview. Okay, sure. So let me go to a new page here. So what would that look like? All right, so here we have a graph. I'm not going to copy the entire graph, but I'm going to get the main features. Okay, that's the best I can do. Okay. So the other important things are that this height here is 3, right? This height is 3. And how far does it take us to go here? This is the x value pi over 2, and this is the x value pi. Okay, is this what yours looks like?
Yeah.
Okay, so the question is find equation of the form a times sine of bx or a times cosine of bx. So one of these two options can be eliminated immediately, I claim. Can someone give me a reason why? Which one I can immediately get rid of and why?
Cosine.
Yes, you're correct. We can throw away cosine, but why?
There's not a sign change and it's even.
Well, it's actually,
Odd.
well, cosine is even. The picture we have here is odd, and there's no shift to the right or to the left. There's no horizontal shift. How do I know there's no horizontal shift? Because they tell us that it's a sine bx or a cosine bx. If there was a shift, there would be like a plus c in there or minus c inside the parentheses, right? That would move us to the right or to the left. So this is the height of the function is going to be just whatever the height of sine of b times x is multiplied by a. So namely, if x is 0, then what is this going to be? B times x would be 0. And what is sine of 0? Always 0. So no matter what you multiply it with, a here, it's going to be 0. And we see that reflected in the graph here. What is cosine of 0? A times cosine of 0 would be what? Would be a times 1, which would be a. So if we are going to take the second thing as our ansatz, or our what is the word for it, as our guess, then this would tell us that the height of the function when the input is 0 is a, but the height of the function when the input is 0 is 0. That would tell us a is 0, which would mean that this whole function would just be equal to 0. And this is clearly not the graph of y equals 0, because y equals 0 would just be a horizontal line. So we can immediately get rid of this as an option. It's not going to be cosine. So we know it's going to be a times sine of b times x. How is the a going to affect the graph of the sine function? To multiply out front by a number, what will that do in terms of transformation?
The amplitude.
Yeah, it's going to give us the amplitude. In particular, as a transformation, it's going to tell us how much we are going to vertically stretch or vertically shrink by. Okay, so to that end, what do we see? We see the height of the function goes from -3 up to 3. What do we think a is?
3.
Close. It is going to have absolute value 3 because we have moved everything. We basically stretched by a factor of 3. But there's something else that happened here, funny. Besides the vertical stretch, what else happened? The normal graph of sine looks like this. So besides the fact that we stretched by a factor of 3, what else did we do?
Reflected it over the
We reflected it across the x-axis. So what is a going to be?
-3.
-3.
Yeah, you got it. -3. It needs to be negative because that's a reflection, and it needs to be 3 because that's how much we vertically stretched by. Okay, so that's a dealt with. How about b? Well, what does multiplying by b on the inside do to the graph of a function?
Changes the period.
Changes the period. What's the period of this function that we see above in this graph?
Pi.
The period is pi, because that's how long it takes for me to have to start repeating, right? You can see I would repeat this segment after pi units, right? Is that clear? So the period is pi. What's the usual period of sine?
2 pi.
The usual period is 2 pi. The period of this graph is pi. So what should b be?
2.
Yeah, good. 2, because I need to have a horizontal shrink by a factor of 2, because the period is half of what it used to be, which means that we need a horizontal shrink by a factor of 2. So that's how I get A, and that's how I get B. That's how I decide that it's sine and not cosine. That's a great problem. Any questions on this one?
What was that method you used to figure out that it wasn't cosine again, what you did with the zeros?
Yes, so that comes from the fact that, look, what does the cosine function look like? Originally, cosine looks like this, something like this, right? Let me do that better. Here's what cosine looks like. Okay. I have a what? Horizontal stretch or compression, vertical stretch or compression. If I compress this picture of this yellow thing, like so, that's not going to change the fact that the height here should be 1. I could stretch it up and down. That would change the height. But it's not going to cause the height to be 0. The only way I could cause the height to be 0 is if I took this whole function and I multiplied the height of every single point on this function by 0. If I did that, what kind of function would I get? It would just look like this. That would be a line. But we know that A can't be 0, right? Because then we would just get this picture. But we know that the picture we get is actually this. So A definitely can't be 0. If A is not 0, then A times cosine of 0 cannot be 0, because cosine of 0 is 1. Cosine of 0 is 1. So if A is not 0, then A times 1 cannot be 0. That makes sense?
Yeah.
In order to transform this yellow graph to look like the blue one, what would we need to do first? The first thing we would need to do is move everything over to the right, because then we would have it passing through the origin here. And then when we multiply the height times any number we want, it's just going to stay right where it is. Okay? But we know that we don't do any kind of left and right moving. I know that I don't do any left and right moving because if I did, it would say A times sine of bx plus something, right? Plus something. This is how we would get a horizontal shift, but I don't see that here, so I know I don't have a horizontal shift. I'm only stretching up and down and stretching left and right. There's no way for me to stretch 1 into 0. There's no way for me to stretch 1 into 0 except by stretching the entire thing vertically by 0, which would give us a line. That's not what we observe in the graph. Does that make sense?
Yeah.
It's kind of high cognitive task here because there's a lot of working parts and you have to think about them in unison, and you have to have a mastery over what kinds of transformations this is going to give us, and what also do the parent functions sine and cosine look like. So to that end, I recommend everyone to basically memorize the basic shape of sine and cosine. Namely, sine starts at 0 and goes up, and then it wiggles. Yes. Cosine starts at 1 and goes down and wiggles. Okay. All right, so that was one question from Lily. So any other questions from anyone else from the homework that you thought were pretty tricky? Okay, doesn't sound like anyone has one. Let me look and see if there's any good ones.
I have a question about 4.3.
Okay, sure. Which one?
It was just like in general. So I think it was number 12. We use, okay, I don't know what it was specifically for that one, but I know for the problems to solve them, we used a mix of r equals the square root of x squared plus y squared for some, and then on the other ones we would use x squared plus y squared equals 1. And I think the difference was that for the ones where we used the r equation, it was a fraction. And then for the other ones, it wasn't. But besides that, I couldn't really figure it out. Do you know what the difference is?
You're talking about question 12 on the 4.3 homework?
Let me make sure it was question 12. Yes.
So secant of theta is 7, tan of theta is larger than 0?
Mine says secant of theta is 4 and sine of theta is larger than 0, but that's the same thing.
Yeah, they're basically the same. So let's see how we do one of those type of problems. So let's try this one. I'm not sure where r is coming into the mix. R usually stands for radius, so I'm a little confused by that. But let's do this problem, and you tell me if this is satisfactory for you. Secant theta is equal to 7. Tan of theta is larger than 0. Find sine of theta. This is what they tell us to do. Find sine of theta. Okay, so here's what we need to do.
This was one of the ones where we used x and y. I just realized, but I think it would still be helpful to do it.
Okay, well, we'll do this one. If you think of the other one, then we can do that too. Okay, so the first thing I do is a trig problem. I'm drawing a unit circle. Okay, so here's my unit circle. Okay, I fucked up the... Let's try to fix that. Oh no. Okay, well, maybe that doesn't look right. That looks right. Okay, so now what do we know? We know that tangent is positive. Which quadrants is tangent going to be positive in?
1 and 3.
Yeah, 1 and 3. It's ASTC. So ASTC. So all and tangent, those are the quadrants in which tangent is going to be positive. So I know that theta is either lying in this quadrant or theta lies in this quadrant. I know one other piece of information though. Secant of theta is 7. If secant of theta is 7, and secant of theta is given by 1 divided by cosine of theta, then cosine of theta must be what? Okay, let's abstract this. If 1 divided by x is equal to 7, how do I get x?
Multiply.
Multiply both sides by x, and I get 1 equals 7x. Then what do I do?
By 7.
Divide by 7. So that tells me x is 1/7, right? So if 1 divided by cosine of theta is 7, then cosine of theta must be
1/7.
yes, 1/7. Because if you divide 1 by 1/7, that's the same as multiplying by the reciprocal, right? The reciprocal of 1/7 would be 7. So that's how we get cosine theta. And what kind of number is 1 over 7? Positive or negative is what I'm looking for, right? It's positive. So what do we know? Tangent is positive and cosine is positive. Which quadrant must I be living in?
The first.
You have to be in the first quadrant because both cosine and tangent are positive. If I'm in the third quadrant, tangent will be the only positive one and cosine would be negative. But cosine's not negative, it's positive. So we know we live in the first quadrant, and 1/7 is going to be the x-coordinate of the point. In fact, we know the point is going to have x-coordinate 1/7. So if going all the way out here would give us the x-coordinate 1, we know that we have to go 1/7 of the way from here to here. So that's going to be something fairly small, right? This is going to be the point. We know that the x-coordinate is 1/7 and the y-coordinate is I don't know. Okay, but we can figure it out. How can we figure it out? Of course, by drawing a triangle. And if we draw this triangle, then what do we know? We know that this length is 1/7. This length is what we want to know, and the length which goes from the center of the circle to the outside should be what? What's the length of this segment?
1.
1, because it's a radius. So how am I going to figure out what y is?
We can use that equation, that x squared plus y squared equals 1.
Good. Pythagorean theorem says length of the short side plus the length of the other side squared is equal to the square of the length of the long side. So that looks like 1 over 7 squared plus y squared is equal to 1 squared. So then y squared will be equal to 1 minus 1 over 49, which means y is equal to the square root of 48 over the square root of 49, which would be 7. And we can simplify that root on top a little bit, and also, what would it be? 48 is 16 times 3, so 4 square root 3 over 7. And that's the y coordinate here. So what is sine of theta?
Four square root 3 over 7.
Yeah, it's just that y value, right? Because sine's job is to put the angle theta in, go to the point on the unit circle, and give us whatever the y value is. We did all of this work to figure out what that y value is, so that is going to be the output of the sine function. Okay, so these ones, there's a game to be played before you even start, which is to figure out which quadrant is theta going to be in. If tangent is positive and 1 over cosine is positive, right? 1 over cosine is positive means that cosine is positive. So if cosine is positive and tangent is positive, we must live in the first quadrant. And so that's how you know where to draw your picture. Okay, figuring out the x-coordinate of the point was done by this equation. 1 over cosine equals 7. That was given. You rearrange this equation to find out what cosine is. Multiply both sides by cosine theta, divide both sides by 7. You get cosine theta equals 1 over 7. So that told us what this x-coordinate is. And then all we had to do was use the Pythagorean theorem. We drew a little triangle and we said, look, the side lengths of this triangle, one of the side lengths is 1/7, so we square that. The other side length, which is short, is y, which is what we want to know. Square that, add them together. That should be equal to whatever the square of the radius is, which conveniently, the radius is 1, so 1 squared is just 1. All right, any questions on that? Okay, is there another one we should talk over?
I found the other one. It was number 11.
Number 11, okay, let me look at number 11. Okay. So number 11 looks pretty similar to me. It says sine of theta equals 4/5. Tan of theta is less than 0. Find secant of theta. Is that right?
Yeah, mine says sine of theta equals negative 24/25. I don't think that would make a difference though.
Yeah, so what do we have? Sine is positive and tangent is negative. Which quadrant am I in?
Two.
Yeah, quadrant 2. So we do a unit circle. This one's even easier than the one we just did. What does it tell us? It tells us that the height of the point is 4/5, and the point is in quadrant 2. So that point would look something like this. And it would have an x coordinate, whatever that may be, and the y coordinate would be 4/5, right? So how would I get x? I would do x squared plus 4/5 squared equals 1. So therefore x is going to be equal to x is going to be equal to 1 minus 16/25, right? Which would be, all right, x squared would be equal to that. So x squared is equal to -9. No, not -9. It's just equal to 9/25. And therefore x is equal to plus or minus 3/5. Take the square root on both sides. But which one do I want? The positive one or the negative one?
The negative one.
I want the negative one because we are in quadrant 2. The x values of points in quadrant 2 are always negative. So we know that this value here is -3/5. So that's the x value. And what is my goal? My goal is to compute secant of theta. What is secant of theta?
One over x.
Yeah, it's 1/x, or if you want, 1 over cosine of theta, which would be 1 divided by -3/5, which dividing by -3/5 is the same as multiplying by -5/3. So we would get -5/3. Does that sound reasonable?
Yeah, that makes sense. I was just confused because in like the way they explained it, they used r equals square root of x squared plus y squared, and then they said that sine was equal to y over r. And I was like, how is the radius? Well, and the problem was 12/37. And I was like, how is the radius 37? And I couldn't get it to work using the x squared plus y squared equals 1. And then I was like, is it not right? Like, I wasn't sure if it was something else.
Yeah, okay. This is because of the following. what we do in our class is we always draw this triangle, which looks like this. Yes? But you can actually draw another triangle. That would be the triangle which looks like this. If you were to draw this triangle, then since sine of this angle is 4/5, then you know that the opposite side has length 4 and the hypotenuse has length 5. Then you can easily ascertain that the other side length should be 3 because it's a 3, 4, 5 triangle. So it's just another visualization of this that incorporates the good old SOHCAHTOA, right? Because sine of this angle will be the opposite divided by the hypotenuse, which is 4/5. So that's how you get this number here. So the way you get the secant is to do the opposite of ka. It would be hypotenuse, which is 5, divided by the adjacent, which would be 3. So you get 5/3, but it needs to be negative because you're in quadrant 2. But look, it's just another way of visualizing the same thing. I don't like teaching it that way because I feel like it's more confusing.
Okay, that makes a lot more sense. Thank you.
Yeah, no problem. So yeah, I mean, the reason that this triangle is going to give us basically the same result is because, look, it's just a bigger version of the one we draw. You see that? If I take this triangle and just make it
Yeah.
bigger, then I get this triangle. So they're similar triangles, so the ratios of the side lengths will be the same. But that's too much geometry for my taste.
Me
Okay. Yeah. All right. Well, that's probably where we're going to have to call it for today. So thanks for your attention, and I'll post this video onto the YouTube channel if you want to re-review it. Okay.
Thank you.
Thank you.
Yeah, no
Yes,
problem.
thank you. Have a good day.
Yeah, you too. Bye bye.